Hello students, welcome to the fourth lecture on the lecture series on ratio and proportions. So in the previous lecture, we were doing some exercise problems. We will continue to do so in this lecture also. Okay, so let's proceed with this lecture. So we'll be covering exercise problems on ratio and proportions. So let's see and start from problem number 1. So there are 3 pumps that can actually fill a swimming pool. So you have a swimming pool. Okay, so there are 3 pumps, P1, P2, P3, and cumulatively they take 8 hours to fill the swimming pool. Okay, in order to fill the swimming pool, they take 8 hours. Okay, so the question asked here that how many pumps do you need? So, how many pumps do we need to fill that same swimming pool within 8 hours? Okay, 3 hours. So in order to fill the swimming pool in 3 hours, how many pumps will we need? So we'll be using the concepts of ratio and proportions to solve this question. So let's denote the number of pumps needed as P. So let number of pumps needed is equal to P. Okay. So using the inverse proportion relationship. So 3 pumps into 8 hours is equal to P pumps into 3 hours, right? Here we use the inverse proportion relationship. What was inverse proportion? If you have a ratio A is to B and if you have a ratio C is to D, and if A is to B is inversely proportional to C is to D, what does this imply? A is to B is directly proportional to D is to C, right? So we'll use this concept. So let's proceed. So we have 3 pumps and 8 hours. So 3 is to 8. Okay. What we have is 3 pumps into 8 hours is equal to P pumps into 3 hours. So this implies that P is equal to what? 3 into 8 by 3. So 3 gets cancelled out. So we need 8 pumps. Right? So all we need is 8 pumps. So if you have a swimming pool that can be filled in 8 hours using 3 pumps, then we can fill same swimming pool in 3 hours using 8 pumps. Okay. So 8 pumps is the final and correct answer here. Okay. So let's see with problem number 2. Okay. So suppose you have 20-liter container. Okay. So you have a container, right? And its capacity is 20 liters. So what does it contains? It contains juice. Okay. That is 25% orange juice. In the juice, what is there? 25% orange juice. So how many liters of pure orange juice should you add to make the mixture 40% orange juice? Okay, so 75% must be water. So what we want to do is we want to keep the amount same. Okay, and what we want to do is we want to increase the percentage that the juice contain of orange from 25 to 40%. Okay, so what we need to do? We need to add more pure orange juice, right? We need to add more pure orange juice. So if we add some X amount of pure orange juice, then the amount converts to 40. So as you can guess right here, we'll let the amount of orange juice needed be X liter. Okay. This is how we will assume and proceed. And at the end, what we will found is X, and that will be the correct answer. Okay. So let's denote the amount of pure orange juice to be added as X liters. As we have already seen, we'll assume this first, then we'll proceed with the calculations and convert this word problem to a algebraic equation and then solve it mathematically so that we arrive at a conclusion for X. Okay. So let's see step number 1. So what we do is we set up the equation for the amount of orange juice in the mixture. So what we do, we convert it to a what? Algebraic equation. So what we have previously is 25 of pure orange juice with 20 liters of what quantity? So it will be what? Plus 1 into x, as this amount is pure 100% orange juice with x amount. Okay. So it will be equal to what? 40% into 20 plus x. So the word problem has been converted to an algebraic equation. So 25 into 20 by 100, right? Plus 1 into x is equal to 40 into 20 plus x whole by 100, right? So let's cancel the hundreds. So 25 into 20 plus 100x is equal to 40 into 20, 800 plus 40x. So this implies that what? This is 500 plus 100x is equal to 800 plus 40x. So this will be equal to what? So this will become 60x is equal to 300. So this implies that x is equal to 300 by 60. That is nothing but 5. So x is equal to 5 is the correct answer. As we solve for x, we have now arrived at a conclusion, that is, what is the number of more pure orange juice in liters to be added so that the orange juice concentration becomes 40% of the total volume. Okay. So as you can see, if you have 20-liter container of juice, that is 25% orange juice. So what you need is, you need only more 5 liter of pure orange juice. Okay. So that is what we need to add to make the mixture 40% orange juice. Okay. The concentration will become 40%. Okay. With volume. So let's proceed with problem number 3. So in problem number 3, what we have is, we have 60-liter mixture of alcohol and water. Okay. So what we have here is alcohol and water. Okay. So the mixture is of 60 liters. So with 25% alcohol, in this 60 liter, alcohol contributes to 25% of it. Okay. So how many liters of this mixture should you replace with pure alcohol to make the mixture 40% alcohol? So this is a similar kind of problem, right? You have a mixture on which you have some concentration of some quantity or some characteristics of some element, and what you need to do is, you need to increase its concentration. Okay. So in order to increase its concentration, what you need to do? You need to add more pure form of that element to the mixture. Okay. So in this case, that element is alcohol, and what we will do to increase its concentration is, we will add more pure alcohol to the mixture. So let's proceed with the solution. Okay. And let's convert this word problem to algebraic equation. Then solve for x. Then solve it. And this will be the solution. Okay. So let's see. Again, what we do is, you assume x is the amount of alcohol that is added to the mixture. Okay. That is, the pure alcohol is added to the mixture. So let's see step number 1. Step number 1 is, what we do is, we set up an equation for the amount of alcohol in the mixture. So what you have is 25% of alcohol in 60% in 60 liter of what? Mixture. So 0.25 into 60. Okay. So this will be what? 40% of alcohol with 60 minus x. Okay. So the final amount of alcohol after replacement. So if we solve for x, so it will be 25 into 60 by 100, right? Is equal to what? 40 into 60 minus x by 100. So 100 hundreds gets cancelled. So this implies that 25 into 60, right? So 25 into 6 into 10 is equal to 40 into 60. So 2400 minus 40x. So this implies that this will be equal to what? 150. So 1500 minus 2400 is equal to minus 40x, right? So this implies that 900 is equal to 40x. So x can be calculated thereafter. So after dividing, so 22.5 is the correct answer. Okay. So what you do is you should replace 22.5 liters of pure alcohol to the mixture. Okay, so that the concentration becomes from 25% to 40%. Okay, in order for this kind of increment, what you need to do is you need to add 22.5 liters of alcohol. So let's see. A chemist has a 120 ml solution of acid with a concentration of 30%. Okay, so we have a chemist here who have 120 ml of solution. Okay, with which concentration of 30%. Acid concentration is 30% in that solution. So how much of this solution should be replaced with 50% acid solution to get a mixture of 40% acid? Okay. So what we want to know is we want to know how much of this solution should be replaced with 50% acid solution to get a mixture with 40% acid. Okay. This is problem number 4. Let's see. This is a slight deviation from the previous two problems. So this is not a big issue. Let's proceed with the solution. So again, what we do is we assume something in order to convert that word problem to an algebraic problem, for which we need to solve for x. So let x be that amount of 30% acid solution to be replaced. Okay. So x is nothing but the amount of 30% acid solution that is need to be replaced. Okay. Not to be added, to be replaced. Okay. This is a keyword here. This is replaced, not added. In the previous two problems, what you saw was x was the amount of some percentage of solution that is need to be added. Okay, or pure element that is needed to be added. But in this case, this is the amount of 30% acid solution that needs to be replaced with 50% acid solution. With 50% acid solution, right? As we have right here, replaced with 50% acid solution. So let's see step-by-step solution. So in step 1, what we do is we set up an equation for the amount of acid in the mixture. So 0.30 into 120, that is initial amount of acid, is equal to what? 0.40 into 120 minus x as the final amount of acid after replacement. So what we do is we need to make sure that acid added from 50% solution will be 0.50x. Okay. So what we do is we get to this equation. Okay. This becomes this. That is 0.30 into 120 is equal to 0.40 into 120 minus x plus 0.50x. So solving for x, 30 into 120 is equal to what? By 100 is equal to 40 into 120 minus x plus 50 by 100 into x, right? So this implies that 30 into 20, so 3, that is 3600 is equal to 40 into 120, that is 4800 minus 40x plus 50x. Okay, so what we are left with is, we are left with 1200 is equal to 10x. So this implies 1200 is equal to 10x imply x is equal to 120, right? So you should be replacing 120 ml of 30% acid solution with the 50% acid solution in order to arrive at 40% acid solution. Okay. What we had previously, 120 ml with 30% acid solution. What we do? We added 120 ml of with 50% acid solution. What we are left with is 240 ml with 40% acid solution. Okay, so this is the final answer. So now our solution amount became 240 and its concentration of acid becomes 40%. Okay, so let's proceed with the next question. So in problem number 5, so what you have here is you have two mixture of sugar and water. So what you have here is a mixture, okay, or you have a mixture of sugar, water. So sugar, water in the ratio 3:2 and 1:4 respectively. So how much of each mixture should you blend to get 15 liters of new solution? So what you want to get is 15 liters of new solution with sugar and water in 2:3 ratio. Okay, so you don't have sugar and water in this ratio, but you have in this ratio and in this ratio. But what you need to do is you need to add these two in such a way that in such an amount that the new ratio becomes this. Okay, so let's proceed with the solution. So you have two mixtures, right? So mixture A and mixture B. So mixture A must have the ratio 3:2, as we only have in ratio 3:2 and 1:4. That is sugar is to water ratio, right? The first part in the ratio becomes is sugar and the second part represents water. Okay. So mixture B has sugar and water in the ratio 1:4. So what you do is, let's assume x liters from mixture A, then you will take 15 minus x liter from mixture B, because cumulatively the both of them becomes 15 liters. So 15 liter is equal to x plus 15 minus x. So we are in right path. Okay. So the assumption is correct here. We assume x liters from mixture A and assume 15 minus x liter from mixture B. So the amount of sugar will become 3/5 into x and the amount of water will become 2/5 into x. So from mixture B, the amount of sugar will be what? 1/5 into 15 minus x and the amount of water will be 4/5 into 15 minus x. So what will happen now is, for the combined 15 liter mixture, amount of sugar will become 2/15 into 2/5 into 15, that is 6 liter, and the amount of water will become 3/5 into 15, that is nothing but 9 liters. So cumulatively both of them, 9 plus 6 is equal to what? 15, right? So 15 liter of content is there. So setting up our equation based on the sugar content, so 3/5x is equal to what? 3/5x is equal to 6 minus 1/5 into 15 minus x, or we can also say that 3/5x plus 1/5 into 15 minus x plus is equal to 6. So explaining and solving. So if we solve this, so what we are left with is 3/5x plus 3 minus 1/5x is equal to 6. So this becomes what? 1/5x is equal to 3 minus 1 is equal to 3. So this implies that x is equal to 15/2. That becomes what? 7.5. So 7.5 liters is the amount of y. Okay. So that is 15 minus x. And x is nothing but 7.5 liters. So you should take 7.5 liters from both mixture A and mixture B to achieve at the desired 2.3 ratio in the 15 liter solution. Let's see the question again. So what we had was, we had 3:2 ratio and 1:4 ratio of sugar and water mixture. Okay. We wanted to achieve at a 15 liter solution with sugar and water with ratio 2:3. Okay. So what we did was, we added 7.5 liter solution from 3:2 and 7.5 liter solution from 1:4. What we arrived at was, we arrived at 15 liter solution from 2:3 ratio sugar, water. Okay, so this is the final answer. So the final answer is 7.5 liters. So let's see problem number 6. So the sum of ages of two friends, that is A and B, is 30 years. If A is 8 years older than B, what are their ages? So what we have here is, we have sum of ages of two friends, A and B. So age of A is equal to what? 30. 30 is the age of A and plus 30 is the age of, age of A plus age of B is equal to 30. Okay. So if A is 8 years older than B, okay. So if let age of B is equal to X, so A is equal to what? X plus 8, as A is 8 years older than B. So what? So we can get a algebraic equation out from here. So a plus b is equal to what? 30. So this implies that b is equal to x, 8 plus x, so 2x. So x plus 8 plus x is equal to 30. So this implies that 2x plus 8 is equal to 30. What we need to do? 2x plus 8 minus 8 is equal to 30 minus 8. So this becomes 2x is equal to 30 minus 8 is equal to 20. So this implies that x is equal to 11. So x is equal to 11 is the correct answer. So age of B. Age of A is equal to what? 20. 19. Right? Because he is 18 years older. So this is nothing but 11 plus 8. Okay. So we have right there now. So let's see. So let's represent A's age and X years and B's age as Y years. Okay. A's age is X years and B's age is Y years. So we are given two pieces of information. So the first information is the sum of their age is what? X plus Y is equal to 30 and B is X is equal to Y plus 8. So substitute the value of X from the second equation into the first equation. So what will be left with is Y plus 8 is equal to 30. So this implies that Y is equal to 11. So Y back into the equation, X is equal to Y plus 8. So X age will be 19. So A is 19-year-old and B is 11-year-old. Okay. So we have now solved it. So the correct answer is A is 19-year-old and B is 11-year-old. So let's see problem number 7. Okay. So the ratio of ages of Ram and Shyam is 5:7. Okay. So the difference between their ages is 12 years. So let age of Shyam be X. Age of Shyam is X. And age of Ram be what? X plus 12. Okay. Because their difference is 12 years. Okay. So let's find their ages. So their ratio is what? 5:7. So basically XY X plus 12. That is age of Shyam is to age of Ram is equal to 7/5. Because we are given the ratio of Ram is to Shyam, but we have evaluated here in the LHS ratio of Shyam is to Ram. So this becomes what? 5x is equal to 7x plus 12 into 7, right? So this becomes what? So we are left with 7x minus 5x is equal to 12. So this implies that 2x is equal to 12. So this implies that x is equal to 6. So x is equal to 6 is the final answer. So solve the second equation for x. So x becomes 6. So now substituting the value of x into the expression of Ram and Shyam's ages, what we are left with is 5x is equal to 30 years and 7x is equal to 42 years. Okay. So these are the ages of Ram and Shyam respectively. So the present age of a father and his son are in the ratio 5:2. So sum of their ages is 49 years. So find their ages. Okay. What we have here is the ratio of a age of father and a son. Okay. The son is of his father. So the sum of their ages is 49. Given that 5x, if we assume their factor to be x, so 5x plus 2x becomes what? 49. So this implies that 7x becomes 49. So this implies that x becomes nothing but 49 by 7 is equal to 7. Okay. So let's represent the father's age as 5x years and the son's age as 2x year. Okay. We represent it as 5x and 2x respectively for the father and son. So we are given two pieces of information. The ratio of their age is 5:2. So father's age by son's age is equal to 5/2. So sum of their ages will be what? 49 is equal to 5x plus 2x. That is given right here. So it will be 7x is equal to 49 as we have previously calculated. So this implies that x is equal to 7 is the answer. So father's age will be 7 into 5 is equal to 35. Father age. Son age is equal to 7 into 2 is equal to 14. So the son is a mere teen with 14-year age. So solving it, what we are left with is 14-year-old son with a 35-year-old father. Okay, these are the final and correct solution. So let's see problem number 9. So the ratio of ages of A, B and C is 4:6:9. So the sum of their ages is 57. Okay, so let their factor be 4x, x, and so it will become what? 6x and 9x. Their sum is what? 4x plus 6x plus 9x is equal to nothing but 19x. So this is equal to 57. So this implies that x is equal to 3 is the answer. So A is will be what? 4 into 3 is equal to 12. So B age will be 6 into 3 is equal to 18 and C age will be 9 into 3 is equal to 27. So this will be the final answer, 27, 18 and 12 respectively for C, B and A. Let's see. Let's A is be represented as 4x, then for B it is 6x, for C it is 9x. So A's age by B's age is equal to 4 by 6, B's age by C's age is equal to 6:9. Okay, so let's see. So the sum of their ages is 57. So 4x plus 6x plus 9x is equal to 57. So solving for x, what we are left with is x is equal to 3. So now substituting the value of x into the expression of A, B and C to evaluate their ages in real time. So it will be becoming 12 years, 18 years and 27 years for A, B and C. As age is 4x, B's age is 6x, C's age is 9x. Okay, so A's real age will be 12 and for B it will be 18 and for C it will be 27 year old. Okay, so we have found the correct answer. Final answer. So let's see problem number 10. A car travels a distance of 180 km in 3 hours. So find its speed in kilometer per hour. Okay, so a car travels a distance of 180 km in 3 hours. So 180 km in 3 hours. This is given here. So we all know the speed and distance formula, that is speed is equal to distance by time. Okay, this is a formula that we have saw time and time again. Okay, and we will be seeing this more often than now. Okay, so just remember this formula. This will be very useful for all the competitive exams. Okay, so what we have here is we don't have the speed here. So let the speed be x. Let speed be x. Okay, so this is equal to what? Distance by time. So distance is given in kilometer, that is 180 km, and the amount of time is given in hours, that is 3 hours. So this is nothing but 60 km per hour. Okay, so the speed of the car is 60 km per hour. So this is the final answer. So the speed of the car is 60 km per hour. Okay, here we use the speed distance time formula, that is 180 km by 3 hours, that is 60 km per hour. So let's see problem number 11. So a train covers a distance of 400 kilometers in 5 hours. So what we have here is we have a distance of 400 kilometer, right? And the train takes from here to here 5 hours to cover the whole journey. Okay, so if continues at the same speed, how long will it take to cover a distance of 800 kilometer? So what we want to calculate is we want to double the distance. Okay, we want to double. Here is 400, here is 800, here is 0. Okay, let's calculate its speed. So speed is equal to what? Distance by time, that is 400 by 5 is equal to 80 kmph. That is 80 km per hour. Okay, so how much time does it take to cover a distance of 800 km per hour? So we have now the speed, that is 80 kmph. So 80, that is equal to, now we are given a distance, that is 800, right? And we don't know the time it will take. This implies that what? Time is equal to 800 by 80, that is equal to 10. So 10 hours it will be taken to cover the distance of 800 km with that same speed, that is 80 km per hour, that we have just evaluated by dividing 400 by 5. Okay, so first we use speed distance time formula to evaluate its speed. Then in order to evaluate the new time frame for the new distance, what we input is we input the speed and distance. in this way, and we are left with 10 hours. Correct answer. Okay.
So that's all for now. Thank you.